Today we are going to be going over the 8.2 guided practice, so writing in logarithmic form. Just to review the parts of logarithmic form, so if I have 3 squared equals 9, this would be an exponential form because it has the base raised to the exponent, and I call the 9 the answer, or what it is equal to. In a log, it goes in the order of base, then the answer, and then the exponent. So B, A, E. With my class, I always show them a picture of an elephant holding a log in his trunk, so that anytime you see the word log, you think of the elephant with his big animal ears. So this will help you remember the order. If it's in exponential form, the base is always tied to the exponent. But if you have the word log, you think of the elephant with his big animal ears. And I yelled that a lot at my pre-calc kids as well. So it's a dumb little mnemonic device, but I think it can be helpful in remembering the order that things go in. So on this first one, we want to write in logarithmic form. So currently, this is in exponential form. That's my base. That's my exponent. That's my answer. So for logarithmic form, it goes in the order of big, base 2. Animal, 32. Ears, which is 5. So there's logarithmic form. For number 2, this is also in exponential form. So 10 is my base, 3 is my exponent, and then 1,000 is my answer. So we write the word log, and we think of the elephant with his big, base 10, animal, 1,000. Ears is 3. Now, this is correct, but could I write it, in a shorter way? Yes, because log base 10 is the same as common log notation. So when I just see the word log without any base explicitly written, that indicates that we have the common log or base 10. So your properest form, if that is a word, would be common log 1,000 equals 3. Any questions on those two? All right. So then moving on to exponential form, the big thing with exponential form or going to exponential form is it should make mathematical sense once you rewrite it. Logs, yeah, maybe aren't as quite as intuitive, but if we go to exponential form, it should make mathematical sense, so that's kind of a way you can check yourself. So I see the word log, and I think of the elephant with his big animal ears. So then my base is 7, my exponent is 3, and my answer is 343. And does that make mathematical sense? Yeah, if you looked on your perfect cube sheet, you would see that 7 cubed is indeed 343. So we wouldn't give you one like 7 to the 343 equals 3. So if you rearrange it that way, that would indicate that you have rewritten it in a false manner. Now, looking at number 4, here we have ln, and folks, it is ln and not in. Occasionally when I check Algebra 2 tests, I'll see an I. So this is L for log natural or natural log. So to write this one in exponential form, first I like to replace natural log with log base E, that nasty little non-terminating, non-repeating decimal. So log base E of 18 equals Y. Now, once I have that base explicitly written there, I think of the elephant with his big animal ears. My base is E, my exponent is Y, and my answer is 18. And that one, unfortunately, we wouldn't be able to check because we have a variable in there, but that is our expression in exponential form. Now, moving on to the next ones with evaluating. How do we evaluate a single log? And this is going to become important later on in the unit once we start solving. To evaluate one log or to solve a one log equation, you always put in exponential form. So we're going to put it in exponential form. So we're actually going to skip number 5 for right now, and we're going to look at number 6 first. So if I try to put this in exponential form, first, since there is no base explicitly written, we can assume that this is the common log or base 10. So we see the word log, and we think of the elephant with his big animal ears. Now the ears or the exponent is what we are looking for. So I'm just going to put a variable there. So we want to find out what this log is equal to. We're going to say that it's equal to x. So then my base is 10. My exponent that goes with that base is x. And then the answer is 1/10. And folks, this takes us back to unit 5, methinks. Unit 5, how do I give a base an attitude so that it sends it to the downstairs of a fraction? What kinds of numbers in the exponent do that? Negative ones. So 10 to the x is equal to 10 to the negative 1. Because 10 to the negative 1 takes it to the downstairs of that fraction and makes it 1/10. So now that these have the same basis, I can cross them off, and we find that x equals negative 1. So that is what this log is equal to. So common log of 1/10 is negative 1. And what's nice about this one is since your calculator has a common log button, you can actually type log 1/10 and you can check yourself. You still have to show this exponential form work, so we don't just want you to show that you can use buttons on your calculator. We want you to be able to demonstrate that you understand that logs are simply a way of rewriting exponential form. Now on number 5, those of you who are all the way through 8.2, change of base formula, ringing a bell? So the change of base formula is important for a problem like this, because if I put this one in exponential form, big animal ears, we get 3 to the x equals 7. Why does that make me ever so sad? Well, 3 to the first is 3. 3 to the second is 9. So is there something friendly I can put in for x to make that true? Or like we did over here, is there a way to write 7 as base 3? Short answer, no. Long answer, no, we can't do that. So how do we solve a problem like this is we are going to use the change of base formula. Which we'll go ahead and write this up here. Change of base says that if I have log of some base and an answer part of the log, we can use common logs to evaluate it. Common log of the answer, meaning log base 10, over common log of the base. So what this means is I can take any log with any base, not just natural log base c, not just common log base 10, I can take any base log and use my calculator to evaluate it. So then, if I wanted to use the change of base formula, on this one, log base 3 of 7 would be equal to common log of the answer, which would be 7, over common log of the base, which would be 3. Now, I forgot my calculator, so if anybody has a calculator, common log of 7 over common log of 3, we should get something relatively nasty. And I think we normally go to 3 decimal places, so make sure you know your rounding rules. 3 decimal places would be the thousands place. So that is how we would work out number 5. For expanding, actually, any questions? Move on to the next ones. So to be honest, I don't use the change of base formula as much. Later on in this unit, we'll get into how we can use logging as an operation. So kind of like we can square root things, but we can also rewrite square roots in exponential form. We'll get into logging as an operation, which I think is a little bit easier than using the change of base formula. So moving down to the next section, we've got expanding and condensing. So the first thing we are going to do is figure out which we are trying to do on these problems. Expand means everything on the land. And for condensing, we want 1 log, and we want to send coefficients to the clouds. So expand everything on the land. That means any exponents you have, we want to move out in front to ground level as a coefficient. And then if we want to condense, we're going to need to send our coefficients to the clouds to be able to condense those. So let's go ahead and start with expanding. And expanding is when you have 1 log and you're trying to turn it into multiple logs. So 7 is an expanding problem since I only have 1 log and we want to turn it into many logs. 10 is expand, and 11 is expand. So expanding, we're taking 1 log and expanding it into many logs, whereas with condensing, we're trying to squish it down into as few logs as possible, namely 1 log. So looking at this first one, if I want to expand, I want everything on the land. Now, personally, what I do is I identify the operation we have going on in the answer part of the log first. So what's joining the answer part of my log together is multiplication. So when we expand, that's going to turn into 2 logs that are joined by addition. So log base 2 of x plus log base 2 of y to the 3rd. So if they're stuck together using multiplication, we expand them by addition of logs. Now, the reason why I like this little rhyme, expand everything on the land, is because that gives me my often missed last step. This power of 3, we're going to use that 3rd kind of weird logarithmic condensing rule that we have, and we are going to move it out in front as a coefficient. The only reason I'm allowed to do this, is because of how logs work. It's a way of rewriting exponential form. So I'm not just kind of like breaking math rules here. It kind of seems like we are just, taking things out of the exponent. But because of what's going on in the background with exponential form, this is a totally legal math maneuver. So we would have log base 2 of x plus 3 as a coefficient, log base 2 of y. So expand everything on the land means we want any powers at ground level out in front as coefficients. So this is expanded as that expression will go. Let's go ahead and move down to number 10 next. On a problem like this, there's a few different ways you can work these. What I usually recommend is simplifying first. So I am powering up this answer part of the log by 3. And if you remember from Mad Spam, m to the a, d to the s, p to the m, when I'm powering up, we multiply the exponents. So the 3 is going to get distributed to the 4, and it's going to get distributed to the y's power of 1. So then I have natural log of x to the 12th over y to the 3rd. So now, identifying the operation I have going on in the log, these answer parts were separated by multiplication, so we expand using addition. These ones are separated by by division, so we are going to use subtraction to expand them. So it's kind of like the opposite of Mad Spam in a way. So this will be natural log of x to the 12th minus natural log of y to the 3rd. So division in the answer part expands to subtraction between the logs. Then, since we are expanding, we want everything on the land, which means we're going to take those powers and move them out in front as coefficients. So 12 natural log x minus 3 natural log y. And that would be our expanded form. And unfortunately, folks, we don't really get into the utility of this too much in Algebra 2. We'll see it a bit when we start solving logarithmic equations, but expanding and condensing, for those of you who think you might go on to take pre-calc and calculus, it's very important for differentiating and integrating expressions. So sometimes you want as many small separate parts as possible. Sometimes having a single expression is easier. So expanding and condensing we'll use a bit for solving, but a lot of its importance doesn't come on until later. So folks, looking at number 11, we've got multiplication in the answer part, so that's going to expand to addition. So log 15 plus log of y to the 6. These are separated by addition because it was multiplication in the answer part. So now, expand everything on the land. We want to move that 6 out in front as a coefficient. So log 15 plus 6 log y. All right, folks, what questions do you have on expansion? Is that coming from next door or upstairs? All right, folks, so let's go ahead and move on to condensing then. So the important thing with condensing is you cannot condense logs that have coefficients out in the front. So your first step on all of these problems is to send your coefficients to the clouds, meaning put them back up in the exponent position. So we're raising them up to the clouds, putting them back up in those exponent positions. So before I can condense these, I have to send the coefficient to the clouds, making that m squared. Send the coefficient to the clouds, making it n cubed. Then these two logs are separated by subtraction, so we are going to condense using division. So we'll have log base 6 of m squared goes on the top, and then n cubed goes on the bottom. If it makes you feel at ease, you can enclose that in parentheses, but the parentheses aren't really required there. So that is now in condensed form. I've got it down to one single logarithmic expression. But your first step for condensing is always to send those coefficients to the clouds first. Looking at numero 9, we've got 5 log base 5 of x plus log base 5 of y. So sending our coefficients to the clouds, we're going to send that 5 back up as a power of the x. And once that coefficient isn't in front anymore, then we can condense. These two logs are separated by addition, so we're going to condense using that opposite operation, or that different operation of multiplying. So we'll have a log base 5 of x to the 5th times y. And there we have it, our condensed single log. Alrighty, folks, so on our last one, since we are condensing, we've got two separate logs. We want to turn it into one log. First step, coefficients to the clouds. Coefficients to the clouds. And, oh boy, so we're going to have, since we're separated by subtraction, we're going to condense by dividing. This one looks like it's going to get gross. So we'll have 12 to the 5th, holy cow, all over 7 to the 3rd. And that simplifies to be, I'm going to cheat and use the pink sheet since I don't have my calculator with me. So 12 to the 5th. Oh, just kidding. I can't even cheat here. So 12 to the 5th is some giant number. And 7 to the 3rd is 343. And I don't believe you can simplify that fraction, but if you could, you would want to do so. So that would be our condensed answer. Questions on any of the problems on here on the guided practice? Alrighty, that concludes the video.